I did my project on the fluid dynamics of Gulf Stream currents. And I actually learned about this over the summer with Dr. Reckinger. I worked with her, and I was a counselor for Base Camp, which is basically where girls from Bridgeport come in and they learn about different ways like they can be involved in STEM. And basically there are 3 ocean phenomena scales. It's small scale, medium scale, and large scale. And a large scale is the thermohaline circulation, which is also known as the conveyor belt. It is driven by the temperature and salt of the water. Thermo stands for heat, as we all know, and haline stands for salt. What I will mostly be focusing on is western boundary currents, like the Gulf Stream current, and these are medium scale ocean phenomena, and they are governed by wind stress, the rotation of the Earth, which is also known as the Coriolis effect, and continental boundaries. In this picture, you can see right here along the North American eastern border, you can see like warm water coming up the stream, and it's actually like the fastest part of the Gulf Stream current. And right about here, you can see it veers off and it starts to head towards Europe. And right here is where like Cape Hatteras is, and it veers off and heads towards Europe near where London and Paris are. And that's about the same latitude as Chicago, and Chicago tends to be a much colder city than London and Paris, and that's due to the warm waters traveling up on the Gulf Stream. And here is a computer model that Dr. Reckinger actually made, and it shows basically, you can see in it how the rotation of the Earth causes there to be this squishing up against this eastern border, which would be where North America is. You can see the vectors along the eastern border are much larger than the vectors over here, which would be where Europe and Africa are a lot smaller. And the Gulf Stream travels from the equator to the North Pole, and the wind stress from 0 to 30 degrees is, the winds are westward, and they're known as the trade winds, and from 30 to 60 degrees are eastward, and they're known as the westerly winds. The direction of the current is clockwise, and the Coriolis effect causes the stream to kind of squish up against the North American border. A couple of years ago, a couple of seniors for their senior design projects made a tank that rotated and simulated the Gulf Stream current, and I have a video of it. And basically this tank is made out of plexiglass, there's water in it, it spins on this board. It's kind of like a record player, I think. And there's a GoPro camera at the top, and it takes a video of it. We put dye in 2 corners of the tank, and you can see the stream of the flow. And this is with everything with wind, the rotation, and the curvature of the Earth. We put a plexiglass in the middle of the tank, you can't see it, and it kind of causes there to be like curvature to show a shallow end and a deeper end of the tank. And you can see the water fastly moving up along the North American border and slowly moving down the Europe and African border, which is what would happen in real life. And it speeds up time. This is without wind. What would happen if there wasn't any wind stress? And you can see the water here where Europe would be. It starts to move back towards the North American border, which does not really happen in real life. And the water down here, where around Florida would be, it never really moved up as fast as it did in the previous video. And this is without the spherical rotation, so we took out the curvature of the Earth in this one. And it's just a lot different. So you can see what kind of happens if you take away one of these governing factors. So the ocean governing equations are basically Newton's equations and Navier-Stokes equations. And we assume that the fluid is incompressible and essentially at constant density. This is one of the equations you can use for a computational model. And right here I've labeled the different parts of the equation and what they basically represent. And you need to apply a grid system domain due to this, because at each location you're going to have different pressure, different temperature, different velocities of the currents, and you're going to have different sea surface height and different salinity. And basically, why do we study ocean currents and the ocean overall? Well, scientists have been getting together for the last 100 years or 50 years, and they've been studying it, and they've come up with different models as to model the ocean's currents, and they've basically unanimously agreed that the climate change is a result of human activity, and the sea level is rising, and the ocean's concentration of carbon dioxide has risen, which causes different animals not to be able to survive in such high acidic climates, or acidic, I don't know, just more, the ocean's more acidic, and animals and plants can't really survive in that. And with this weather change, the thermal circulation has been altered, which ultimately will alter the climate patterns, and this has increased more natural disasters. So, any questions?